Hey guys, so we're going to be looking a little bit more about continuity before we move on to the next topic. So this is going to be a short video, but there'll be a longer one coming along later today. So in the last video, what we talked about was continuity, and specifically we talked about continuity of, different kinds of functions, but mostly we did piecewise defined functions and, I think that's it mostly, right? And a few functions with holes. So in this lecture, what we want to talk about is, what? Kind of piecewise defined functions again, but kind of one specific problem really. So let's remember our definition of continuity. So definition of continuity. F of x is continuous at x equals a if the limit as x approaches a of f of x equals f of a. And you can extend that to talk about like a function on an interval or something like that. So we could say a function is continuous. A function is continuous on an interval, let's say AB. That could be any type of interval, so if you want to replace that with like AB like that, that's fine. A function is continuous on an interval if f of x, function f of x, is continuous at every point inside the interval. Right. So if we look at a function like this, I'm going to draw just a simple function here. So like, let's say that's 1, and like let's say that's 2, and then let's say that's 3, and that's 4. And so if I take a function that goes like this, right, and let's say that this is y equals f of x here, and I say, here's an example, is, why does that look so dumb? Is f of x continuous on 1 to 3? Right? So of course 1's here, 3's here, so this is the interval. Then the answer is no, right? Because at 2 there's a problem. No, because it's not continuous at 2. Right? But if I say, is f of x continuous on 3 to 4? Yes. Right? Because it's not continuous at 2, but 2's not in 3 to 4. So it's fine. Okay? And that's it pretty much for continuity on an interval. You can extend that interval to everywhere and just ask if a function is continuous. Okay, and they do that. So like here's an example of that kind of thing from the book. So they might ask you something like this. They might say, here's f of x. F of x is piecewise defined, negative x squared minus 2, 3x minus 2, 7, and then this is if x is less than or equal to negative 3. This is if negative 3 is less than x, which is less than positive 3, and this is if 3 is less than x. So x is greater than 3. Okay, and so I don't want to go into too much detail here graphing this, but I'll do a little just to explain what's going on. Let's look at this last piece first because it's going to be the easiest to graph. So that says if x is greater than 3, the y value is 7. So if I come up here to, I don't know, let's put it here. Let's see, 1, 2, 3. There's 3. And we need to go up to 7 at least. So let's go like, let's say 2, 4, 6, 8. That way we can fit it. So that's what that piece looks like, right? The function value is 7 for x values greater than 3. Well, then you got to graph the next piece. So the next piece is here, 3x minus 2 if x is between -3 and +3. Well, if you plug in a 3 here, what do you get? So if I plug a 3 into this piece here, I actually don't want to call it f. If you plug a 3 into this piece right here, you get 3 times 3 minus 2, which is 7, right? And let's put in the -3 as well. If you put a -3 in there, you get 3 -3 minus 2, which is -9 minus 2, which is -11. So down here, it looks like we actually need to go a little bit further. So 2, 4, 6, 8, 10, 12, and those are all negative. And let's go 1, 2. Nope, that's not how we were numbering them. Let's go 1, 2, 3, negative, 4, negative. Okay, so at -3, we're supposed to be down at -11. That's down here. Should that be open? Actually, yeah, it should be open. So let's erase that. So that should be an open circle right there. And then at +3, we're supposed to be up at 7, which is where this empty circle is. So what you can do is say, okay, well, we need to connect the dots here, but this one should be a solid dot. Because that's the equals 3. So that fills it in, fills in that empty circle. So then we're on our last function here. This one, oops, that's not what I was trying to do. Plot this one. Again, you can plug in, what do we have to plug in there? A -3. So if you put a -3 in there, you're going to get -3 squared minus 2, which is -3 squared is 9 minus 9 minus 2. That's -11 again. So it actually goes through this point here. And what kind of graph is it? So it looks like it's a parabola that opens down. So I'm not gonna plot that very carefully, but something like that. Because this is kind of like if you continued the graph would come up to 0 there, but of course it doesn't because it starts at -3. So there you go. There's your function. So then the question there, which I never asked, but the question here is this continuous? Is it continuous? Yes. Right? Even though it's piecewise, it's continuous because there's no holes and there's no breaks, there's no jumps, there's nothing, right? So there you go. It's a continuous graph. What else can we do? Well, what else can we say? I think that's it, right? The thing that you want to have paid attention to is how we determined that this was continuous basically boiled down to just checking, like, here's a piece, and they had to match up right there, right? So that there wouldn't be a hole. And, here's a piece, and here's a piece of the piecewise defined graph, and they happen to match up right there. And so there's not a hole. So because they carefully came up with the formulas here, this piecewise defined graph has no holes in it, and it has no holes in it, so that makes it continuous. okay? But that's not always going to happen, right? So some of them are going to be not continuous, okay? And you're going to need to check them. So, yeah, let's see here. I'm going to find one that's not continuous real quick. Spoiler. Come on. Give me one that's not continuous. That's all I want. All right, here's one. So f of x is equal to negative 0.25 x squared minus 0.375 x minus 2.875, and that's if x is less than minus 3. Then we have minus 2 if x is equal to minus 3. And then we have minus 0.5 x squared minus 1.5x minus 4 if x is greater than negative 3. Now, everything in this one happens at negative 3, right? Like that's the only like switchover point. That's 3, negative 3, that's negative 3, that's negative 3. So if you think about what you actually need for continuity here, you would need, I'm not going to graph it. Instead of graphing it like I did the last one, I'm going to just evaluate limits. So for continuity at x equals negative 3, which is the only place that could be a problem, we can check these three things. So the first thing you need to check is the limit as x approaches negative 3 from the left of f, which we'll do. You also need to check the limit as x approaches negative 3 from the right of f of x, which we'll do. And we also need to evaluate f of minus 3. Okay. Now f of minus 3 is going to be the easiest here. So if we look at that function and say, what's f of minus 3? Then you should be able to figure out right away that you're just looking right there, right? So it's just a minus 2. So that's easy. Now what about the other two things? So for the other two things, you actually have to work out a limit. So let's do limit as x approaches 3 from the left. Negative 3. Oh, why write bad? Approaches minus 3 from the left. Okay. Minus 3 from the left. What function do we use? So if we're to the left side of negative 3, then we should be using this top function because that's the one that's to the left of negative 3. So you substitute in that formula here, negative 0.25x squared minus 0.375x minus 2.875. And in order to evaluate that limit, because it's just a polynomial, you're just going to plug in minus 3. So plug in minus 3. It's going to be a little bit tricky here. I don't have very much space. So I'm going to plug in minus 3 and then just write the result. So if you plug in minus 3 into this first term, you're going to get minus 3 squared is 9 and then times negative quarter. So that's negative 9 over 4. Okay. Now if you put in a negative 3 into the next one, you have negative 3 times 0.375. So I'm bad at math, so I'm going to use a calculator here. But on my computer, so you can't see it. So what are we doing? 0.375 times 3, which is 1.125. It's 9 over 8. And that'll be positive, so plus 9 over 8. And then minus 2.875, which is minus 2.875. So I'm going to calculate this on my calculator here. I've got negative 9 over 4 plus 9 over 8 minus 2.875. So I do that, and I get negative 4. Okay? Yes, that is correct. All right, so that's the answer. But we're already done with the problem then, because the limit from the left is negative 4, and the function value is negative 2, and those aren't the same, right? So how could we meet this definition of continuity? We need the limit and the function value are supposed to be the same. But they're not, because the limit, if it even exists, the limit is negative 4, but the function value is negative 2. So we don't even have to do this third one here. You could, but if you did, there's no value that it could be that would make all 3 of these equal, because we already have 2 of them that aren't equal. Okay, so since all 3 aren't equal here, things aren't equal, f is not continuous. At x equals minus 3. There you go. All right, so that's how you work out continuity for piecewise defined functions. Basically, you check all 3 of these things at every point where it crosses or where it switches from one function to the next function. Okay, and we did an example of that in the last one, but last lecture, but we did it again. Now there's another type of problem, which now I hope to find it. Yeah, here we go. So another problem type, which is not hard, but you just need somebody to show you how to do it, is this idea. So they give you a question like this. They say, let f of x equal piecewise defined function. I'm going to go k minus 5x and kx plus 9. This is going to be if x is less than 1, negative 1, and this is going to be if x is greater than or equal to minus 1. Okay, and what they want is they want you to find k to make this continuous. Okay, so it's a little bit different. They're not asking you if it's continuous. They're telling you that it's continuous, but what's k that will make it continuous? And here's the idea. So we know that if it's continuous, then the graph will be like this, where the pieces match up, where the function switches. And if it's not continuous, it'll be like this, where the pieces don't match up. Okay, so we just need to check, or we need to make them match up. So the idea is, if you have a graph like this, where you have negative 1 on here, then you have 2 different functions. They're straight lines. So like basically this one is on the left side of 1, so it's like this. And the other one is on the right side, and so it's like this, right? But depending on k, you know, it might look like this. So what happens is, oh, that's crooked, but I'm not fixing it. If you pick the right k, then instead of being like this, where there's a gap, you might get lucky and they just match up perfectly. Okay, so this would be the wrong k value, and this would be the right k value. So how do we make it so that it's the picture on the right? Well, it's actually really simple. Basically, you just go back to that same thing we looked at before, where you need the limit to equal the function value. So you have a limit as x approaches -1 from the left of f of x, a limit as x approaches -1 from the right of f of x, and then you have f of -1. And you work those all out, okay? Just like before. So we have the limit as x approaches -1 from the left of, well, to the left side of 1, you're in this first function. So you put in k minus 5x. And go ahead and work that out. So you plug a -1 in for x, not for k, for x, and see what you get. You get, in this case, k plus 5, right? It still has a k in it because we don't know k. For the next one, you have the limit as x approaches -1 from the right. Well, what function are we using if we're on the right side of -1? We'll be using the other one, right? Kx plus 9. So you go kx plus 9. Put in a -1. You put in a -1, you're going to get negative k plus 9. So that's 9 minus k. Okay. Now the last one, you have f of -1. Well, which one of these do you use if you have x, or x equals -1? This one again, right? Because of the equals there. So you put in -1 there again, and you get same thing, 9 minus k. All right. Now you've got this number, and this number, and they're all supposed to be equal. If it's continuous, they're all equal, right? So all of these are equal, all equal if f is continuous, right? They're supposed to, we're trying to make it so that they go through the same point at -1. And since they both have a k, we don't know the exact point it is yet, but we're going to make it happen because we can set them equal to each other. So we need them all to be equal, so just set them equal. So you just say k plus 5 must equal 9 minus k. And then you solve it. Right? So you just set these equal. That and that. I mean, and that, but they're, you don't need all three because two of them are the same. And you just solve it for k. So in this case, you would just move the k over to the left and have 2k plus 5 equals 9. And then you would minus 4, why would you minus 4? That doesn't make sense. You would minus 5, and you'll get 2k equals 4. Divide both sides by 2, and you'll get k equals 2. And so that's it. So it's k equals 2. So that's your answer. All right, and so just to check this, so what do we have there? K equals, let's see, let me write this down on a sheet of paper, and then we're going to go to Desmos to plot this. So this is k minus 5x and kx plus 9. That's greater than -1, less than -1. Okay, so let's go plot it. So I'm going to look at a graph here. So I'm going to go to desmos.com for plotting. I will go into projector mode to make it nicer for you guys to see. Projector mode. Okay, so let's do this. So if I type an equation up here, I can just say like y equals k x. No, not kx. K minus 5x. Minus 5x. And let's add a slider for k. And let's also add another thing. How do I get curly braces here? I think they'll give them to me. There we go. X less than minus 1. Hey, why? How do I? 1. How do I put in the curly brace? I guess I don't. So that's what we got there. And if you change the slider here, you can see what different k values do. Now the other one was kx plus 9. So I have to type that in. Kx plus 9. And, I could say y equals, but I didn't. And it's still going, so that's good. X, this is greater than or equal to minus 1. Okay. So those are the two pieces, right? Kx plus 9 and k minus 5x. And if you move this around, you see, look, they don't match up, they don't match up, they don't match up. Where do they match up? Right, oops, almost. Right there. Every time I take my finger off, it changes. There. Right, you see how they match up? They match up when I put a 2 there. If I could just type it in right. Okay, there we go. That makes a match up. So you put in a 2, they match up. If you put in any other number, they don't match up. But we found it with algebra. I guess we could have just done it this way. Okay. Let's see, back here. Let's do one more of those. Maybe. Briefly. Okay, one more real quick, and then that'll be it. So, example. Same problem, right? You're going to have to do this a few times. K plus 4x, that's if x less than negative 2. Negative x if x is greater than or equal to negative 2. How would you do it? Well, let's be a little bit faster than last time. Negative 2 from the left. If we're to the left of negative 2, which function should we be using? This one, right? K plus 4x. Plug in a negative 2. What do we get? K minus 8. Then you have limit as x approaches 2 from the right. What are we going to get? Just a negative x, right? The other function. It's negative 2. Put in a negative 2. What do we get? We get 4. You also need f of negative 2, which is going to be... Whoa. Why did I say 4? You put in a negative 2. Negative 2 is just 2. And same thing here. Negative 2 is just 2. So all of these need to be equal. All equal. So we need k minus 8 to equal 2. So add 8. What do we get? We get k equals 10. That's the one that does it. Okay, so these are not that bad. You just need to know how to do this. And, you can use Desmos if you want. If you use Desmos to help you, just pay attention to how I use those curly braces to limit the x values. Okay, so you just type in the function. You don't even need the y equals. You can just type in the k whatevers, and it'll ask if you want to add a slider, and you add a slider, and then you can just do that back and forth until they match. All right. So anyway, that is it for this lecture. We are going to have another probably 2 or 3 lectures today, actually, because I'm so far behind. But that's it for right now.